Yo, I don't think we should talk about this.
Come on, why not?
People might misunderstand what we're trying to say, you know? But that's a part of life.
Let's talk about this, baby. Let's talk about you and me. Let's talk about all the good things and the bad things that may be. Let's talk about sex.
Ethereum started with a simple incentivization mechanism for miners to include transactions in a block. The user would submit a transaction with a maximum gas limit for executing the transaction, for example, 100,000 gas units, and a gas price, for example, 9 gwei. Hence, the maximum fee that the user would pay in this case would be 900,000 gwei. If the transaction only consumes 50,000 gas units, then the miner is rewarded 50,000 gas units multiplied by the gas price, so 450,000 gwei. And the user gets refunded the rest of 50,000 gas units multiplied by the gas price. This is now called a legacy type transaction, and it is still supported in Ethereum. Then EIP 1559 came and said that miners should not get all the transaction cost. They should only get the priority fee that the users set aside for them. So we start again from 100,000 gas units as gas limit at a maximum price of 9 gwei. Users are refunded the gas that has not been used, and the rest is split into a base fee and a priority fee. The base fee is the amount of gas used multiplied by the current block's base fee per gas unit, which is dynamic and can change from block to block based on how full the blocks are. The priority fee is the amount of gas used multiplied by the priority fee per gas unit, and this goes entirely to miners to incentivize them to include your transaction faster. The base fee is burned. Now let's look at how we can split these fees and make the most out of them, because the user needs to pay them anyway. Let's look at the base fee. This base fee is burned by EIP 1559. But for analysis purposes, we can also split this into an intrinsic fee, which is the intrinsic gas cost of the transaction, around 21,000 gas units, multiplied by the block's base fee per gas, in this case 147,000 gwei, and the cost of the actual code execution, which is 203,000 gwei in this example. We can take this intrinsic cost, which is very similar for each transaction, and we can burn it, or even fund core development with it. You can think of it as a core protocol burn or fee. The execution gas cost can be directed for funding development efforts for the smart contract called by the transaction, or it can be split between miners and block producers and developers. But there is another category, service maintainers. This becomes especially relevant when you think about precompiles. For example, I previously demoed an IPFS precompile, and you could have a service fee attached to the precompile. In the IPFS example, you could have a fee for pinning the file created and paying for the storage. So developer funding can be done on protocol level with the advantage of having less friction and no additional fees incurred by the users. Transaction fee distribution to developers is not new. For example, it is currently being implemented on Evmos, but you have now seen a didactic analysis of how it can be done at a high level for Ethereum or any EVM-based chain.
Let's talk